Domain. The first thing we want to talk about are the two domain restrictions we know about to this point. The first is fractions. When we have a fraction where x is in the denominator, remember we cannot divide by 0, and it's possible that we could use values of x that may make the denominator 0. So we have to make sure that our denominator does not equal 0, and if anything does make the denominator equal 0, we disallow those values. The next is with radicals if the index is even. Because remember, the even roots of negative numbers are imaginary. Therefore, we're going to go ahead and make the restriction that the radicand, or the stuff that is underneath the radical sign, must be greater than or equal to 0. That way we're restricted to taking even roots of non-negative numbers. Let's try a few problems here. We're going to get the domain and place it in interval notation. We start out with this type of an expression, and it is a fraction where we have an x in the denominator. Our restriction states that the denominator cannot equal 0. So I'm going to replace denominator with what the denominator is, and then I'm going to solve that inequality. I know that x cannot equal -7. Graphically, here's -7, and x can take any value except for -7. So in interval notation, we'll write -∞ to -7, union -7 to +∞. On the next problem, I have another denominator where I have an x. So I'm going to have to, first off, factor that denominator. Okay, I have x minus 2 and x minus 3 in the denominator. And I know, again, my denominator cannot equal 0. So that means that x minus 2 and x minus 3 cannot equal 0. So x minus 2 cannot equal 0. X minus 3 cannot equal 0. So x cannot equal 2, and x cannot equal 3. In other words, on the number line, I can use any numbers except for 2 and 3. I can even use the numbers between 2 and 3. So my domain in interval notation is going to be -∞ to 2, union 2 to 3, union 3 to +∞. On this next problem, again, I have x in the denominator. I know that the denominator cannot equal 0, so I'm going to state that here. The denominator cannot equal 0. And I try to solve this inequality. X squared cannot equal -1. Well, I know that that could only happen if we had imaginary numbers here. It's only the square of I that would give us -1. So in other words, all real numbers could be used here. So my domain is from -∞ to +∞. If you want to look at it from a number theory standpoint, think about x squared plus 1, where x is any negative number. If you square a negative number, it makes it positive, and then you add 1, it just makes it larger. If you would take a positive number and square it, it's positive. You add 1, it makes it larger. If you would use 0, 0 squared is 0 plus 1 is definitely not equal to 0. And we've covered all of the real numbers that way. So we know that the domain is all real numbers from negative infinity to positive infinity. With our next problem, we are looking at the cube root of x minus 1. Now remember, we had a restriction with radicals, but that restriction is only with even roots. This is an odd root, so we have no restriction on this domain. Don't waste your time trying to set anything up on it. And it's just negative infinity to infinity for the domain. How about something like this? It is an even root, it's a square root. I know that 8 minus 3x must be greater than or equal to 0. We state that because if it were less than 0, then we would be taking the square root of a negative number and we would get an imaginary answer. So we want 8 minus 3x to be greater than or equal to 0. So I have negative 3x greater than equal to negative 8. I'm going to divide both sides by negative 3. Remember, that's going to flip your inequality and make it 8/3. So x must be less than or equal to 8/3. If I would graph this, then I'm looking at something like this. Or in other words, in interval notation, from negative infinity to 8/3 inclusive is my domain. On this last problem, we're taking a fourth root of x squared minus 1. And again, it's an even root, so we do have a restriction. X squared minus 1 must be greater than or equal to 0. We can't solve this the way we did here. We're going to have to do a little bit more work. Remember, it's a quadratic or a nonlinear with an inequality, so we're going to have to set up a sign chart. First, let's factor and then start making our sign chart. The critical values I get from my factors would be a -1 and a +1. My factors are x plus 1 and x minus 1. And I test somewhere over here. Let's maybe try a -2. -2 plus 1 is negative. -2 minus 1 is negative. And a negative times a negative is positive. Let's try a 0. 0 plus 1 is positive. 0 minus 1 is negative. And a positive times a negative is negative. Let's test something over here. Maybe a 2. 2 plus 1 is positive, 2 minus 1 is positive, and a positive times a positive is positive. Alright, we wanted something that was greater than or equal to 0, so that means we're going to pick our intervals that tested positive, and I'm going to include the endpoints. So my domain is negative infinity to -1, union +1 to positive infinity.